There are two core concepts in measurement that use that classical test theory equation that we were talking about before, about a true score and an error, and are used to evaluate how well instruments do. And when critically appraising instruments, you want to think about these two core concepts. People should describe these when they talk about how good their measurements are. The first concept is reliability, and the second concept is validity. Reliability is the idea that a measure measures a thing, and it measures that thing over time or over people. There's different forms of reliability, and we'll list what some of those are. But the core element of reliability is that there is a thing that the measurement instrument is measuring. And sometimes we might think of this as a dependability measure. Do two people using the instrument get the same result? We can think of it as a consistency idea. If I use this instrument at multiple different times, do I get the same answer? So whether it's different people using the instrument or different times where the instrument is being used, I want the instrument to behave exactly the same over time or place or whoever's using it. So if you think about a ruler, the ruler is a very reliable instrument. I can put the ruler down and I measure distance, and it doesn't matter whether I'm on the moon, whether I'm underwater, whether I'm measuring an apple, or whether I'm measuring a baby. The instrument is going to be the same and operate the same way. That ruler is going to operate the same way no matter who's using it, no matter what the environment it's being used in. It is a reliable measure of distance. There are several different types of reliability. There's inter-rater or inter-observer reliability. So if I have two clinicians go in and interview the same patient, do they diagnose them the same way? That's inter-rater or inter-observer reliability. There's test-retest reliability. If I have you go in and do a diagnostic procedure on a person, and then I go in and have you do the same diagnostic procedure on the person, do you get the same answer both times? There's multiple forms reliability. Does each type of measurement I'm using, and whether I use the DSM or the ICD-10, do they both produce the same kind of diagnostic measurement? And then there's internal consistency, which means, does my scale measure a single thing? Does it behave the same? Do all the questions ask about the same kind of thing rather than everything in the world? So inter-rater or inter-observer reliability, as I mentioned before, is the ability of a measure, whether it's a diagnostic assessment using the DSM or any tool, to behave the same no matter who is using or administering that instrument. And so it's consistency over observations. So whoever is observing or doing the measurement has to consistently be able to apply that instrument to the population. And in order to do this, you can just look at, if I have two people diagnosing somebody, are their diagnoses strongly correlated? If I'm observing somebody and I say, oh, that person has bipolar, and you observe that person, you say that person has schizoaffective disorder, that is a low correlation. If we both agree, if we have concurrence that that person has bipolar disorder using this instrument, then that would be evidence of high inter-rater reliability. So correlations between different observers are the tool we use to assess inter-rater reliability. Test-retest reliability is about assessing the reliability of an instrument over multiple time points. So if I use an instrument to measure somebody's depression at time 1, and then I go back and I measure their depression at time 2, are those measurements consistent across time? And the way we also assess that is by correlating the measure over time. The measure should be highly correlated if I measure you at time 1 and at time 2, assuming that nothing changed between time 1 and time 2. So the correlation between those two measures, how strongly they're associated with one another, is how I assess and evaluate test-retest reliability. When assessing composite measures, where I use a lot of different questions to ask about a single construct, whether it's depression or whatever, I want all of those items to measure one thing. So I want them to hold together very well, and that is called internal consistency reliability. So for example, if I ask you a question about eco-friendliness, how eco-friendly are you? And I would expect all of the following responses to these questions to be strongly correlated. I participate in available recycling programs. I prefer to buy products made from recycled products. Conserving resources is important to me. I get bored easily. I am concerned about the state of the environment. Wait, one of these things is not like the other. And ironically, if you were bored through this lecture, you probably missed the fact that item number 3 was, I'm bored easily. Well, that's not something that's measuring eco-friendliness. The others, whether it's about recycling programs or concerned about the environment or controlling your resource use, those are all items that tap into this concept of eco-friendliness, whereas being bored is not related to eco-friendliness. So that item would have poor internal consistency with the other items because it's unrelated to the construct of interest, eco-friendliness. And we measure this through a tool called Cronbach's alpha, and it's a pretty simple thing to appraise. Cronbach's alpha runs from 0 to 1, 1 being a perfect correlation between all the items, 0 being no correlation between all the items. If you have below 0.5, that's a crappy measure, and it should be considered very unreliable. 5 to 6 is a pretty poor measure. 6 to 7 is a mediocre measure. It's not horrible, but it's not great. And then anything over 7 is a pretty good measure. So when appraising the use of scales, authors should tell you what the Cronbach's alpha or what the internal consistency of those measures are as a good check on their use of that instrument. And you want to see numbers like 0.7, 0.8, 0.9, which are indicative of good internal consistency, meaning they have they have high levels of reliability and low levels of systematic error. Validity is the other concept, the partner concept to reliability in assessing measurement. Whereas reliability is about the question, are we measuring a thing? Validity is the question, are we measuring the thing that we want to measure? There are several types of validity. The most basic type of validity is face validity. And face validity is, does the measurement seem valid? You'll recall on the previous, when I was talking about internal consistency, I used this eco-friendliness example and asking about recycling or concern for the environment or resource use all seem like eco-friendly kinds of questions. They are face valid questions. The question about being bored is not a face valid question. It's a question that's totally unrelated to you can be bored and eco-friendly or be totally motivated and not bored by anything and eco-friendly. Boredom has nothing to do with eco-friendliness. And so that has low face validity. So face validity is this idea that's just a judgment call. Does this item look like it's measuring the thing I'm interested in measuring? Content validity is about does the item, do the items and does the measure the area, the content that I want to cover. So if I'm asking about depression and I want to assess your depression and I just ask you, have you lost your appetite and have you had problems sleeping? Well, those are actual depression measures, but they don't cover the full content of depression. That's why in the DSM you have to have depressed mood or loss of interest, anhedonia, in order for those other symptoms to make sense, because the full range of the context, the full range of the content of depression requires depressed mood, and as a result of depressed mood, having problems with sleep or appetite. So sleep or appetite tell us something about depression, but they tell us things about lots of things. Outside of assessing whether somebody has depressed mood or anhedonia, sleep or appetite don't tell us a whole bunch about depression. So if we want to assess the content validity of a depression measure, we can't just ask about sleep or appetite or weight. We also have to ask about depressed mood. So we have to cover the full range of the content. And just like face validity is a judgment call, content validity is also a judgment call. A more rigorous and much more useful form of validity is called criterion validity. And that's where we check the measurement instrument against some objective criteria. So for example, if I want to measure how good you are, how likely you are to be a good student, I can use a tool like the SAT or the GRE. But I can then compare how well the SAT or the GRE predict grades in school. Because there's actually a measure that tells me how good you were in school. It's your grades. And if the SAT is strongly correlated with grades, then that is evidence of high criterion validity. I have used the criterion of grades to assess the validity of the SAT or the GRE. And criterion validity comes in two forms, predictive and concurrent. I just gave you an example of predictive validity. The SAT happens before your grades, and so if I observe high levels of the SAT and then later on I collect your grades, I've predicted, or hopefully, well, if you're the SAT author, hopefully predicted your grades with the SAT. Sometimes I can measure things concurrently, and that's called concurrent criterion validity, and that's when the same thing is happening at the same time. So if I'm assessing how well you can hit a baseball by observing your swing, I can simultaneously observe whether you hit the baseball. And so those two assessments, both my assessment of the quality of your swing and whether you hit the ball, are occurring at the same time. That's concurrent. But in both cases, we have a criterion, whether it's grades in school or the ability to hit a ball, that are being used to tell us whether the instrument that we're using is a valid instrument. And finally, there's construct validity. And construct validity is similar to criterion validity. It's a little bit different, where I'm using similar constructs to say that the thing I'm measuring either converges with things it should converge or diverges from things that it should diverge with. So if I have a measurement of depression, that measurement of depression should be strongly related to sadness or lack of activity or lower quality of life. It should be concurrent with those. It should be strongly correlated. It should be uncorrelated with things like hyperactivity. It should be uncorrelated with things like happiness, life satisfaction, things that are the opposite of depression. Often you'll see in measurement more subtle uses of this construct validity. So for example, I want my depression measures to be loosely correlated with anxiety. I don't want them to be anxiety measures. I want them to be depression measures. And so sometimes you want them to come close but skirt by other constructs. So construct validity is a powerful tool that we use to assess the validity of instruments. And finally, a word about the relationship between reliability and validity. An instrument can be reliable but not valid. An instrument cannot be valid but not reliable. Why? So here you see a picture of what a reliable and valid instrument looks like in the use of an archery target. So because all of the dots, which are my measurement observations, are tightly compact, I am a reliable archer. Because they hit the center, I'm a valid archer. I am consistent in the application of my archery skills. Incidentally, if this were actually me, you wouldn't see any dots because I can't shoot an arrow. But in this hypothetical world where I'm a reliable and valid archer, the dots are tightly compact and they're where I want them to be. I am measuring the thing I want to measure, and I am measuring a thing. I can reliably hit a spot on the target, but it's not the spot that I want to hit. So my instrument here is reliable, but not valid. However, if there's no reliability, if I'm all over the place, I can't measure the thing I want to measure. So reliability is a prerequisite for validity, whereas you can have an instrument that is reliable, but not valid.